what is the value of y or f of x. Good. If it's 0, we get 0 here. If it's pi over 6, for example, this is pi over 6, then we have 1/2. If this is 1, then we have 1/2 somewhere here. But we know that from 0 to pi over 6 is not going to be line like this. We cannot just connect it as a line. So from 0 on the circle here, from 0 to pi over 6, this is a curve. So it will go something like this. Then at pi half, if it's pi half, then we will get 1. So it will hit 1 here. If you plug like 3 pi over, like 3 pi over 3, no, 2 pi over 3, which is 120. 120 will be here, and the value of the value of the height, it will get to 0 at pi. Then at 3 pi half, it will get to -1. And at 2 pi, it will get 0. So we graph 1 revolution. So this is a period of the sine. The period means when the distance from 0 to 2 pi, this graph, it changes. And after 2 pi, it goes back to the same height, same distance. And if you put -pi over 6, for example, you're going to have something like this. So it doesn't have an end. The coffee machine is noisy. I think it's done. My coffee is ready. So I will be more nicer to you guys after having coffee. So chapter 4 is about the graph. And the good thing is you have a graphing calculator. You can just graph it. If I ask you guys graph y equal to like sine of x, I mean, if it's exactly that, you can just graph it. And if it's multiple choice, you need to pick, is that going to be like this? Is that going to be like that? Or like this? Or parabola? So selecting multiple choices will be very simple. But same as that, you know the graph of parabola or a circle or a line that you have it in your mind that how they look like. The graph of sine of x, you should know is like this one. Good. So important things about the periodic graph is a period. What's the period of the graph? The period of sine of x and cosine of x is from 0 to 2 pi. This much is a period of the graph. We also need to know what amplitude. This height, it will be the amplitude. So amplitude of sine of x, it will be 1. So if I can spell amplitude, it would I have it here actually. Amplitude. Amplitude is a height from the x-axis. So now y equal to, just let's talk about periodic graph. I give you 4 graphs, 1, 16. So which one here you can select more than one is periodic graph. So the word periodic means it will repeat. So from negative infinity to positive infinity, the graph repeats. Is that aperiodic? Is a periodic graph.
A and C.
Karen, very good. Yeah, the graph of A, it looks like it repeats the same thing, correct? This is, let's say it continues to the negative and positive infinity, but we don't see a pattern there. There's no pattern. I mean, that's not periodic. So on the first one, we were able to see a pattern that this is keep repeating periodic, but this much and then like this, they don't have anything in common. So that's not the periodic. And C also is periodic. I mean, you can go start from here, then again goes like this, then it goes like this. So the shape is this much, it repeats all the time. And for A, this is the graph will repeats all the time. And D is gonna go this way to negative, positive and negative infinity. This is not a periodic, it doesn't repeat. It's just only a line. Good. So you have an idea about periodic function. If a graph is a periodic function or periodic graph, then you need to find the amplitude and you need to find the period of the graph. Also also periodic, there is a midline as well. The midline is a line that cut the graph. For example, for C, we can see this is this line, which is x-axis, it cut the graph exactly half, makes it amplitude here and amplitude there is a height. But we don't have an amplitude for this type of graph. If this is a midline, this much we have no idea because we're going to go to positive infinity, and that one going to go to negative infinity. So we don't have amplitude for that type of graph, which is a graph of tangent and cotangent. Am I going too fast with all the coffee, or you guys want me to drink my coffee?
So far, so good.
So I mean, the chapter 4 with the calculator and like a half a page of notes, you're good to go. I mean, this will be very easy set of homework and exam and quiz. So I'm going to give you guys a periodic graph. Let's say this is one of the graph. Good. It repeats. And let's say X and Y axis is right there. This is X and that's Y. If I ask you guys what is the amplitude of this graph? So the amplitude, in order to find the amplitude, for the graph of sine, it was here, correct? We said this is the amplitude. But in order to find that amplitude, we need to make a line go through to cut it. They call it midline. Then this height and that height, this one, it will be same. If you cut it the way it has to be same, then that's the line you're looking for. And this is going to be, for example, y equal to 8. Let's call it, this is 8. This is 4, 2, 6, and 8. Good. And this much will be the amplitude. And if the maximum is 12, correct? No, it should be 10. What do you think the amplitude of this graph will be? So this is 8, correct? This is 10, and this is 6. So what's the distance from here to the maximum? I didn't pick this one to here. No, it has to be the bump, they call it the maximum point. So if this line is 8, that's 10, so the amplitude is 2. This is 2. So all of them, it will repeat 2. That's the amplitude. Any question for the amplitude? So amplitude is not the distance from maximum to the minimum. They'll give us 4, correct? That's not it. So maximum minus minimum divided by 2, that might give you amplitude on the graph. For example, the maximum value here is 10 minus minimum value here is 6 divided by 2 is 4 divided by 2 is 2, correct? I just made up a formula, but or from the midline to top or bottom will be the amplitude. An amplitude never going to be negative. If we have a graph here, the amplitude, for example, going to be this distance. When we are on the negative side, doesn't mean amplitude going to be negative. No, amplitude always going to be positive because we're talking about the height. Let's have, so here amplitude is 2. Example, y equal to 2 sine of x. This one has an amplitude of 2 as well. This 2 actually works as an amplitude. Another example, y equal to 52, y 52, 53 sine of x. What is the amplitude of this equation or of this graph? Any suggestion?
53.
Yes, 53. Actually, the number that multiply by sine or cosine, that would be the amplitude. So the amplitude here is 53. So if you want to, if for example, you want to visualize this one, if you want to use the, if you graph it, the graph will be something like this. It's going to go all the way to 53, all the way to negative 53. So this how it works, the graph of 53 sine. So I'm going to put here 53, and I'm going to put here negative 53. So that's the amplitude. Let's have one spicier amplitude question for you guys. Y equal to negative 8 sine of x, what is the amplitude? If I ask Karen, I'm sure she knows. Karen, what's the amplitude?
-A.
No. Good try. Jake is still is connecting. Jake, what's the amplitude? Morocco. So Karen had the suggestion was good, 8. So I said this amplitude is 2, this amplitude is 53. So she said, oh, why not -8? Before we just submit this in, for example, the homework -8, you need to put absolute value of -8. Because we just learned the amplitude, the height, never going to be negative number. So amplitude always is positive. So in order to make it positive, you put absolute value. So the formula for you have in your note sheet, if you have y equal to a sine of x, amplitude will be absolute value of a. This also works for a cosine of x. Good. So this is absolute value will be amplitude. Now let's have another example. What was that? So many notes. I'm not able to copy the URL, so I don't know. Somebody has problem. So example, y equal to -20 cosine of x. What is the amplitude?
-20.
Very good. Absolute value of -20, which is 20. So you learn about amplitudes, about sine and cosine, and the midline. That's the line that exactly cut the graph of periodic graph by 2 pieces. Let's go back to what we had here. So now about period of the graph. So the period will be the shortest distance that the graph will repeat after that. So for example, let's pick a good color, blue always high. So when you see the graph, so there are different techniques to find the period of the graph. You can start from any place you want. For example, I will start from here. I will start from here, correct? Let's say here is, I'm going to put 5. And this is 15. Then we keep going, right? So I start from one part of the graph. I go up. So far, I'm going above. I'm just tracing the graph. So I go up to here. So far, I didn't repeat anything. Whatever point I went was brand new. For example, this point was 8 and 5, and this point, all of them was brand new. Then I come here. Again, we have all the points that I'm touching. Those are, I never touched it before. Good. Go here until here. So from here goes here. The curve was brand new. All the area was good. But I'm going again up. So when I'm going up, at this point, it's similar that I'm repeating the value of y again. So at this point, I'm repeating the same thing, correct? So this much or this much will be the period of the graph. It repeats. This much will be the period. So all the period will be same. So you can pick any distance and that would be period. And so it looks like the period will be 10 from 15 to 5. The distance is 10. So each 10 inches or 10 minutes, it repeats. Right? Does that make sense about that? Good. So periodic graph has a period. I didn't pick from here all the way to here. I know from here to there, again, it repeats similar, but that's not the shortest one. I'm looking, the shortest one is 10. 20 is not the answer, or 30 is not the answer. So must be the shortest one, shortest distance. And the graph y equal to like a sine of x, the period of sine of x and cosine of x is 2 pi. If you see graph of sine, it repeats at 2 pi. All right, let's make it a little spicy for you guys. Y equal to sine of 2x. We got a graph this. So in order to graph, first of all, you have a graph of sine in your note sheets. This is from 0 and 2 pi, and the amplitude is 1. This is y equal to sine of x. Good. But I'm asking to graph y equal to sine of 2x. For graph of y equal to sine of x, this is x, that's y. If it was 0, sine of 0 was 0. I'm going to do the same thing here. This is x, that's y. If it's 0, we have 0. We have sine of 2 times 0, which is same as sine of 0 will be 0. Good. So now I'm going to make a room here. This is 0. This is pi. This is pi. That much is pi. This is 2 pi. This is 3 pi half. So I just want to show you guys how the graph changes when there is a number here. So when it's 0, 0, both of them are 0. So this is 0, and both of them showing the point. What about if is pi half? For example, pi half. And this is pi half. Sine of pi half equal to 1. So the blue one, pi half, it was 1 here. That's the original graph. Actually, I can just graph the sine of x here. Good. It repeats and repeats. This is what you have it in your note sheet. Now what in 2x, so we're going to have sine of 2 times pi half. This gives us sine of pi, and sine of pi is 0. So what's happening? At pi half, for this graph, it hit 0 again. So first we had 0, so definitely something happening there. I cannot just connect it like this. Let's see what's happening at pi over 4. At pi over 4, sine of pi over 4 was root 2 over 2. But here, sine of pi, root 2 over 2, for example, somewhere here. But sine of 2 times pi over 4 gives us sine of pi half, which is 1. So at pi over 4, this is going to go to 1 somewhere here. So it's going to go up, and it's going to go down to here. And here at 3 pi half is going to go here. At pi, sine of pi was 0. But when I put pi here, I will get 2 pi. Sine of 2 pi is 0. So what's happening? The graph, this graph of sine of x, the period was in 2 pi, but graph of sine of 2x, everything happens between 0 and pi. So the period got half. So now I'm going to continue same. So the period become pi for sine of 2x. I know I just that's a little confusing for you guys. I think I messed it up the way I was explaining, yeah? So the point is, when we have a number here, which is multiplied by that x or an angle, the period will get shrink or sometimes get bigger. The formula is, for example, sine of bx. If we have y equal to sine of bx, the period of this graph will be 2 pi over b. This is a formula to find the period of a graph for sine and cosine. All right. This type of, the way I graphed it, again, you have a graphing calculator, there's a computer, you can just graph it. But your job is, when you see an equation, before you're graphing it, you should be able to tell me what is the period and what is the amplitude of the graph. So let's come up with the expensive formula, which is y equal to a sine of bx. Amplitude will be absolute value of a. Period of the graph, usually they put it with t, will be 2 pi over b. This happens, this formula holds for sine, also works for cosine. Good. So there are two important things about periodic function, amplitude and period. If I give you equation, it's very easy to come up with, use this formula and come up with the amplitude and period. But if I give you graph, it might be little challenging than this one. So now let's have a few examples. Example, y equal to 5 sine of 4x. What is the amplitude and what is the period of this graph? So let's have another question. F of x, so don't freak out. F of x is same as y equal to -3 sine of just sine of half x. Oops. 1/2 x. If I ask you guys to graph it, you just look at the graphing calculator or you just put it in the computer, you see beautiful graph. My question is, what is the amplitude and what is the period of this graph? Marakel, you looks like you're moving there something. You want to say something?
Amplitude is 3.
Very good. Amplitude is 3.
I got pi 4 or 4 pi for period.
Beautiful. Very nice. So amplitude is absolute value of -3 equal to 3. We love it. We use the formula. And period is 2 pi over b. In our case, b equal to 1/2, which is going to be 2 pi over 1/2. We need to simplify this. Now that we have a fancy calculator, we bought it in Amazon, but you cannot plug it in you cannot plug pi in it. I believe Elizabeth knows that we cannot plug 2 pi over 1/2. So we're gonna have 2 pi over 1/2. We use our cheating formula. 2 times 2 pi is 4 pi. Divided by 1 will be 4 pi. So 4 pi will be the period. I don't want you guys lose point to see for this little algebra, but you can say 2 pi divided by 1/2. This is same as 2 pi multiplied by 2 over 1. Correct? We change it to multiplication by flipping the other part. It gives us 4 pi. 2 pi times 2 is 4 pi. Now the graph. A So I'm going to just graph one period of that. I'll make it a little spicy for you guys. That's B, C, so we have 3, -3, 3, -3, 3, -3, 3, -3, and period we said 4 pi. So here we have 4 pi, we have 2 pi. 4 pi, 2 pi, 4 pi, All right, let's see who will answer this.
C.
Jason, yeah, Jason says C. Can you ask your calculator why?
Yeah, I mean, I've tried to graph on my calculator. It didn't work. I don't know
Oh, it
what's going
didn't
on.
work? It didn't work?
Yeah, it's probably user error. Yeah.
Yeah, when you're using your calculator, you need to make sure the window of your calculator, the maximum, minimum is super important. I mean, you need to make it to the radiant, and if we cannot fit it, it gives you error. But you picked a good one. C is correct. So this multiple choice was very tricky because all of them, they're sharing the same amplitude and same period. So all of them, they had that correctly. So why is A is not correct? A is a graph of sine, correct? This is sine of, this is like a 3 sine of 1/2 of x. But it gives you exactly the same. But we had negative. This negative will flip this, the same transformation going to be like this. It will be like this. We just flip it on the x-axis, which we will get C. Any question here? All right. Let's have another one. Y equal to 5 plus sine of x. What is amplitude? What is period of this graph? No, what did you do? You hacked to my system. So what is amplitude now?
Absolute value 5.
All right, Noor, you make the day rainy, the sun gonna go. So, so this A, which is part of the amplitude, is multiplied by sine. This 5 is not multiplied by sine. The number that multiplied by sine is 1. So amplitude will be absolute value of 1 will be 1. This 5, nothing to do with absolute value. All right, guys, when it's plus or minus, doesn't do. We're going to see it in the graph. What about period of the graph? Who thinks the period will be? Jason, what's period?
I'd guess 2 pi.
Very good. Yeah. We follow the rule. I mean, again, this is a formula 2 pi over b. What is b? There's no number here, it's 1 only, correct? So we're going to say 2 pi over 1, which is 2 pi. So we have the period, we have the amplitude. So this, on your note sheet, this is a graph of sine that we have, correct? Again, this is continue, but I don't want to just continue to ever, but we have 0 to 2 pi, correct? So this is a graph of sine, y equal to sine of x. What this 5 will do to the graph? What should we do with this 5? We just shifted 5 units up. That's all, same as before. So we're gonna move it up. For example, this is 1. It will be something like this. Well, mess it up. It will be something like this. So exactly same shape, but we move it 5 units up. What is a period? Period will be from here. Why did I graph it like this? I can't even copy. So the graph will be now we have difficulty of graphing. So we move it 5 units up, correct? So this point was 0, right now is 5. This is 6 because this was 1, we move it 5 units up. What is amplitude? Amplitude, we said this is a midline, the line that cut it, and this is gonna be the 1, and that's gonna be 1. So exactly same as that. All right, so when we have adding or subtracting, nothing will happen to the period or amplitude of the graph. All right, guys, I think this is